Preparing for a healthcare data engineering at HCA Healthcare interview? You've reached Candy Mentor, and this video is for you. We'll walk through 25 key questions you're likely to face. For each question you'll see a sample answer followed by the key points to cover. Subscribe, like, and share, and drop a topic request in the comments. Question 1. How would you design an end-to-end healthcare data pipeline for HCA Healthcare? I would build a layered, metadata-driven pipeline. Source adapters ingest HL7 messages, FHIR resources, claims, and clinical extracts into an encrypted landing zone. Validation checks schema, required fields, identifiers, timestamps, and terminology before quarantine or promotion. Transformations create standardized clinical models, while curated tables serve analytics and reporting. Orchestration manages dependencies and retries. Monitoring tracks latency, completeness, duplicates, and failures. I would enforce least privilege, audit access, and retain immutable raw data for traceability. While answering, cover source systems, HL7 and FHIR ingestion, validation, privacy controls, raw and curated layers, orchestration, monitoring, lineage, quality checks, downstream analytics, and disaster recovery. Question 2. How would you build a reliable ETL process for patient and encounter data? The main challenge is producing consistent records despite corrections, duplicates, and late arrivals. I would extract incrementally using source update timestamps or change data capture, then land immutable batches. A business key such as patient and encounter identifiers supports deduplication, while deterministic transformations make reruns idempotent. I would reconcile source counts and financial totals, handle late data with watermarks and reprocessing windows, and preserve history where required. Alerts would distinguish data quality failures from infrastructure failures. Make sure to cover extraction strategies, incremental loading, source watermark logic, deduplication, surrogate keys, slowly changing dimensions, late arriving data, reconciliation, idempotency, and operational alerting. Question 3. What challenges do you expect when processing HL7 version 2 messages? HL7 v2 is flexible but inconsistent across facilities and vendors. I would parse delimiters from the MSH segment, validate message type and version, and map segments such as PID, PV1, ORC, and OBX into canonical structures. The pipeline should generate technical and business acknowledgements, preserve the original message, and route malformed records to quarantine. I would also handle repeated fields, missing values, duplicate deliveries, and out-of-order events using message identifiers and timestamps. In your answer, discuss segment structure, delimiters, optional fields, repeating values, message types, acknowledgements, version differences, malformed messages, ordering, duplicates, and clinical validation. Question 4. How would you transform HL7 version 2 messages into FHIR resources? I would first define a canonical mapping rather than translating fields mechanically. PID becomes patient, PV1 generally maps to encounter, and clinical observations map to observation with references to patients, encounters, practitioners, and devices. Identifiers need explicit systems, while local codes should map to standard terminologies when possible. I would validate generated resources against the target FHIR profile, preserve provenance, retain unmapped source data, and document extensions for information without a clean standard representation. Be sure to mention canonical mappings, patient and encounter relationships, identifiers, terminology normalization, references, extensions, provenance, validation, version compatibility, and handling information that lacks direct FHIR equivalence. Question 5. What is FHIR, and how is it different from HL7 version 2? FHIR is a modern healthcare interoperability standard built around modular resources such as patient, observation, and medication request. It commonly uses RESTful operations and JSON or XML, with profiles and terminology bindings defining local requirements. HL7 v2 is primarily an event-driven messaging standard composed of delimited segments and is deeply embedded in hospital interfaces. I would not treat FHIR as an automatic replacement. Many organizations ingest V2 internally while exposing governed FHIR APIs externally. Focus on FHIR resources, RESTful APIs, JSON and XML, profiles, terminology, references, modern interoperability, HL7 version 2 messaging, implementation variation, and when each standard is appropriate. Question 6. How would you ensure patient identity is resolved across multiple hospital systems? I would establish an enterprise patient identifier and maintain crosswalks to source system identifiers. Deterministic rules can match strong identifiers, while probabilistic matching can compare name, date of birth, address, phone, and other demographics. High confidence matches flow automatically, ambiguous cases require review. I would maintain a golden record with survivorship rules, version every merge or unmerge, and audit decisions. Preventing false positives is especially important because linking two patients incorrectly can create serious clinical and privacy risks. Discuss enterprise identifiers, deterministic and probabilistic matching, demographics, confidence thresholds, survivorship, golden records, manual review, false matches, merge handling, and auditability. Question 7. How would you design data quality checks for clinical data pipelines? I would define quality dimensions with measurable rules at each layer. Examples include required patient identifiers, valid timestamps, unique message IDs, referential integrity between encounters and patients, acceptable clinical value formats, and delivery latency thresholds. Failed records should be quarantined with actionable reasons instead of silently dropped. Dashboards would show trends by facility and source, and alert thresholds would reflect business impact. I would assign owners and track remediation, because monitoring without corrective action does not improve data quality. Cover completeness, validity, consistency, uniqueness, timeliness, referential integrity, clinical ranges, profiling, threshold-based alerts, quarantines, ownership, remediation, and quality dashboards. Question 8. How would you make a healthcare pipeline idempotent and safe to rerun? An idempotent pipeline produces the same result when the same input is processed repeatedly. I would preserve immutable raw files or messages, assign stable event keys, and use deterministic transformations. Target loads would use transactional merges or partition replacement rather than blind appends. Checkpoints record completed units, while replay operates from a known input boundary. After reruns, reconciliation compares counts and hashes. This design supports recovery from failures without creating duplicate encounters or observations. Mention immutable raw inputs, deterministic transformations, natural or event keys, merge semantics, checkpoints, transaction boundaries, replay, deduplication, and verification after recovery. Question 9. How would you handle late arriving and out-of-order clinical events? I distinguish event time, when care occurred, from processing time, when the pipeline received the record. The system can use watermarks with a bounded lateness window for normal delays, then run correction jobs for older events. Events should carry source sequence numbers or timestamps when available, but I would avoid assuming global ordering. Curated tables must support updates and historical reprocessing. Consumers should understand that recent reporting windows may be revised as delayed clinical data arrives. In your answer, address event time versus processing time, watermarks, lateness windows, correction events, reprocessing, historical partitions, ordering guarantees, and downstream consistency. Question 10. How would you secure FHIR in a cloud-based data platform? I would treat FHIR protection as a platform-wide control, not just a database feature. Data is encrypted in transit and at rest using centrally managed keys, with private endpoints and restricted network paths. IAM follows least privilege, separation of duties, and short-lived credentials. Sensitive columns can be tokenized or masked for development and analytics. Comprehensive access logs, retention policies, vulnerability monitoring, and tested incident procedures support HIPAA-aligned governance. I would also verify vendor agreements and permitted services. Be sure to cover HIPAA obligations, encryption in transit and at rest, key management, private networking, IAM, least privilege, masking, tokenization, auditing, retention, and incident response. Question 11. What cloud architecture would you choose for a scalable healthcare data lakehouse? I would use durable object storage as the foundation, with bronze data preserving source fidelity, silver data providing validated canonical structures, and gold data serving governed use cases. An open transactional table format can provide ACID behavior, schema evolution, and time travel. Compute should scale independently from storage, with separate workloads for ingestion, transformation, and analytics. A central catalog controls discovery and permissions. Partitioning should follow access patterns, while lifecycle policies and workload scheduling manage cost. Discuss object storage, bronze, silver, gold layers, open table formats, schema evolution, compute separation, catalogs, workload isolation, governance, partitioning, and cost management. Question 12. How would you optimize a slow Spark or distributed ETL job? I would start with the execution plan and stage metrics rather than guessing. I would reduce scanned data through column pruning and predicate pushdown, choose sensible partition sizes, and broadcast genuinely small reference tables. For skewed keys, I might salt partitions or use specialized joins. Excessive small files require compaction, while unnecessary caching wastes memory. I would compare runtime, shuffle volume, spill, and cost before and after each change, preserving correctness and reproducibility. Cover execution plans, partition sizing, shuffle reduction, broadcast joins, predicate pushdown, file compaction, skew handling, caching decisions, parallelism, and performance measurement. Question 13. How would you implement CDC from an operational healthcare database? I prefer log-based CDC because it minimizes load on operational systems and captures inserts, updates, and deletes. Each change should include a source position, transaction metadata, operation type, and event timestamp. The consumer stores offsets durably and applies ordered, idempotent merges into the target. I would plan for schema evolution, retention of change logs, replays from checkpoints, and delete semantics. Validation compares source and target counts while avoiding intrusive queries against clinical production systems. Mention log-based capture, inserts, updates, deletes, ordering, transaction boundaries, offsets, schema changes, replay, privacy, downstream merges, and source system impact. Question 14. How would you design an ingestion service for real-time HL7 messages? I would place a secure interface engine or ingestion service between source systems and a durable message broker. The producer receives an immediate technical acknowledgement only after safely persisting the message. Consumers validate and transform asynchronously, using message IDs for deduplication and partitioning by an appropriate entity when ordering matters. Transient failures trigger bounded retries. Poison messages go to a dead letter queue with full context. Raw messages remain replayable, and metrics cover throughput, lag, errors, and acknowledgement rates. Focus on secure transport, message brokers, acknowledgements, partitioning, ordering, retries, dead letter queues, duplicate detection, backpressure, observability, and replayable storage. Question 15. How would you expose clinical data through FHIR API? I would expose only well-defined FHIR resources and profiles, backed by a canonical data model rather than ad hoc queries. The API would support appropriate search parameters, pagination, conditional operations, and explicit versioning. OAuth scopes and role-based policies limit access by application and context, while audit events capture use of sensitive records. Validation enforces profiles and terminology bindings. Caching can improve safe read performance, but authorization must be evaluated carefully so cached responses never cross patient boundaries. Discuss resource modeling, REST operations, search parameters, profiles, authorization, scopes, pagination, rate limits, versioning, audit events, validation, and performance safeguards. Question 16. How would you model encounters, observations, medications, and patients for analytics? I would define grain before choosing tables. A fact table might represent one observation result, one medication event, or one encounter, while conformed dimensions represent patient, facility, provider, and terminology. Patient identifiers would be surrogate and enterprise-aware, with restricted access to direct identifiers. Encounter relationships connect clinical events without duplicating patient attributes excessively. Slowly changing dimensions preserve relevant historical context, and effective timestamps distinguish when an event occurred from when it was loaded. Cover dimensional versus normalized modeling, conformed patient and facility dimensions, encounter facts, clinical events, terminology keys, temporal validity, grain, and slowly changing attributes. Question 17. How would you reconcile data between an EHR and an enterprise warehouse? I would reconcile at multiple levels: batch counts, distinct patient and encounter keys, field completeness, and business totals such as charges or lab results. Comparisons must use aligned extraction windows and account for updates, cancellations, and late arrivals. Exceptions should include source identifiers and explainable reasons, not just a failure count. I would define source of truth rules for conflicting attributes, trend reconciliation metrics, and obtain sign-off from data owners before labeling the pipeline production ready. Mention record counts, control totals, key coverage, financial and clinical measures, timing windows, sampling, source of truth decisions, exception reports, and repeatable reconciliation. Question 18. How would you implement data lineage and governance for FHIR? I would catalog datasets, fields, definitions, owners, classifications, retention rules, and permitted uses. Pipeline metadata should capture source to target lineage at table and, where practical, column level. FHIR tags can drive masking and access policies automatically. Audit logs show who accessed or changed data, while stewardship workflows manage definitions and quality issues. Before modifying a source or transformation, lineage enables impact analysis. Governance should make compliant use easier, not create undocumented manual gates. Be sure to include business and technical metadata, column-level lineage, data owners, classifications, cataloging, retention, access policies, consent, auditability, and impact analysis. Question 19. How would you handle schema evolution in HL7, FHIR, and warehouse tables? I would detect source and FHIR versions explicitly and keep parsers or mappings version aware. Additive fields can usually be introduced compatibly, while renamed or reinterpreted fields require migration and consumer communication. Contract tests validate representative messages and resources before deployment. I would preserve raw payloads, make new warehouse columns nullable initially, and quarantine incompatible records with clear diagnostics. A schema registry or metadata catalog helps coordinate changes across producers, pipelines, and downstream consumers. Discuss version detection, backward compatibility, contract testing, additive changes, nullable fields, profile validation, migration strategy, quarantine, consumer communication, and metadata-driven parsing. Question 20. How would you test a healthcare ETL pipeline before production deployment? I would test transformations with unit cases covering normal, missing, repeated, malformed, and corrected clinical values. Integration tests verify connectors, message acknowledgements, warehouse merges, and external contracts. Reconciliation tests compare known source fixtures with expected outputs, while privacy tests confirm masking and authorization. Performance and failure injection tests validate throughput and recovery. I would use synthetic or de-identified data, automate tests in C, CD, and require explicit quality, security, and operational sign-offs. Cover unit, integration, contract, reconciliation, negative, privacy, performance, recovery, representative clinical cases, synthetic data, automated C, CD, and release criteria. Question 21. How would you monitor and operate a production healthcare data pipeline? I would monitor both technical health and data health. Technical metrics include throughput, queue lag, job duration, retries, resource usage, and failures. Data metrics include freshness, volume anomalies, completeness, duplicate rates, schema drift, and reconciliation results. Alerts should be severity-based and linked to runbooks with clear ownership. Correlation IDs and structured logs support tracing from an input message to curated output. Service-level objectives should reflect clinical and business impact rather than infrastructure availability alone. Discuss freshness, throughput, lag, failure rates, completeness, quality scores, cost, distributed tracing, dashboards, severity-based alerts, runbooks, ownership, and service-level objectives. Question 22. How would you recover a pipeline after a cloud region or service failure? I would begin with defined RPO and RTO targets for each data product. Raw data and critical metadata should replicate across failure domains, while infrastructure and permissions are reproducible through code. Checkpoints allow processing to resume without duplicating outputs, and immutable raw data supports replay if state is lost. Backups must include catalogs, schemas, secrets references, and operational configuration. I would test regional recovery regularly, validate reconciliations afterward, and perform failback deliberately. Mention recovery point and time objectives, multi-zone or regional redundancy, replicated storage, infrastructure as code, checkpointing, replay, secrets, dependency testing, and controlled failback. Question 23. How would you balance batch and streaming processing for clinical analytics? Streaming is valuable for time-sensitive alerts, operational dashboards, and near real-time interoperability, while batch is simpler and often cheaper for historical reporting. I would use a durable event layer so both paths can replay the same inputs. Shared validation and transformation logic reduces divergence, although streaming requires stronger handling for state, ordering, and late data. The right choice depends on clinical latency requirements. I would not introduce streaming where hourly or daily freshness is sufficient. Compare latency, complexity, cost, consistency, replay, operational burden, use cases, event time handling, and a unified architecture that avoids duplicate business logic. Question 24. Describe a time you would reject or quarantine a healthcare data record instead of loading it. I would quarantine a record when loading it could create an unsafe interpretation, such as an unknown patient identifier, invalid event time, broken required structure, or ambiguous medication code. The quarantine should preserve the original payload, source metadata, validation errors, and correlation ID. I would alert the responsible interface owner, correct the mapping or source issue, and replay the record after approval. Non-critical missing values may be defaulted only when documented and clinically safe. Focus on unsafe or ambiguous identifiers, invalid timestamps, schema violations, terminology errors, quarantine design, feedback, replay, clinical risk, and avoiding silent data loss. Question 25. How would you explain a complex healthcare data engineering decision to clinical and business stakeholders? I start with the decision's impact: data freshness, report accuracy, clinician workflow, privacy, or cost. I avoid unexplained technical jargon and use a simple lineage diagram plus concrete examples, such as how a delayed encounter changes a metric. I clarify definitions and assumptions with data owners, present alternatives and risks, and document the decision. For sensitive workflows, I request clinical validation before release. Clear communication is part of data quality because misunderstood metrics create operational harm. Mention translating technical trade-offs into patient and operational impact, clarifying requirements, visualizing lineage, discussing risks, documenting assumptions, validating definitions, and building stakeholder trust. If you are still with us, congratulations, you are much ahead of the rest and serious about preparing for your interview. We hope we were able to add value to your preparation and create some helpful content. Do not forget to like and share this video. Your small act can do great things for us.